The next component of a partial plan to consider are the variable bindings. We've already seen that every time we add a new instance of an operator to our plan, we introduce a new copy of the variables of that operator into our plan. But of course, our solution plan must contain actions, which are fully ground instances of operators. The variable bindings simply help us to keep track of the possible values for all these variables that we're introducing into our plan with the new actions. But they can do more than that. They can also contain co-designation constraints, which says a variable of one operator must have the same value as the variable of another operator, but we don't know what that value is yet. So we can have constraints on the equality or inequality of variables in our plan. Again, when we add variable bindings as a plan refinement operation to our partial plan, we want to stick to the least commitment principle. So we only want to add variable binding constraints when we have a good reason for doing so. And the most important reason for adding variable constraints is, of course, that we need to turn all the operator instances, the partial actions in our plan, into fully ground actions. But this is not the only reason. In fact, we've already seen that when we introduce a causal link to use an effect to support a precondition, then the effect may have variables, but the preconditions may have specific values in there. So we need to unify these to make sure that the effect and the precondition match. And that is the second reason for introducing variable binding constraints. And here is our example again. I've dropped the second action simply to save some space. So you remember we've introduced this causal link here from the effect to the goal condition to record that we've introduced this action to support this goal condition. Now with this action, of course, we've also introduced a new set of variables R1, L1 and M1, moving the robot R1 from location L1 to location M1. And initially our variable bindings were all empty. So this is the table of variable bindings we maintain, and it contains the three variables we've just introduced, R1, L1 and M1, and there's no constraints on these variables. Note that I've shown the variables in the operator as red because there's no indication what values these might have. But of course they need to have specific values to support the goal conditions we want to support. And adding variable binding constraints ensures that this unification will succeed. So here's how this works. We add variable bindings. We say that R1 must become the value robot and M1 must become the location log2. Also, the two variables R1 and M1 in the operator are now black because we have values for these variables. L1, on the other hand, remains undefined. Now, one thing that can happen is that the other effect of this operator interferes with the goal. So we had the effect not at R1, L1, which can of course also unify with the goal we're looking at. This would be a problem because one of the effects is positive and the other is negative. So what we can do is introduce a new variable binding constraint that says the value of L1 cannot be location 2. In that case, the unification can never happen and we're done. The threat is gone. We have also introduced another causal link from the initial state to our new move operator to support one of its preconditions. Again, we need variable binding constraints to make sure the unification succeeds. And in this case, we would add a variable binding constraint that says the value of L1 must be log1, and that is consistent with it not being log2. While this looks quite simple, note that the maintenance of consistency between the variable binding constraints is actually a complex problem. The final plan refinement operation we have is to add ordering constraints to our plan. Ordering constraints, the final component of a partial plan, are simply binary relations that specify the temporal order between actions in our plan. And there are quite a few reasons we may consider for adding ordering constraints to our plan, some of which we've already seen. So the first reason for an ordering constraint is quite trivial, namely that all actions must come after the initial state, and similarly all action must come before the goal. We never add actions before the initial state, and we never add actions after the goal. And this can be enforced with ordering constraints. then we've already seen that a causal link implies an ordering constraint. The final reason is a little more complex, and it is to avoid possible interference between the actions in our plan. Remember that I told you that an action can interfere with a causal link if it has a negative effect that interferes with a positive condition on a causal link. Adding ordering constraints is one way to get rid of this possible interference. Returning to our example, the first thing that you may note is that the second action has reappeared. This is simply because I'm not showing you the variable binding constraints anymore, but they are of course still there. You can see this in the color of the variables of the different operators. The red variables are the ones that still need a value, whereas the black ones are fully ground by the variable bindings. What this diagram still shows are the dotted arrows representing causal links, and I've already told you earlier that each causal link implies an ordering constraint. So I will add those here. For the 3 causal links, we need 3 corresponding ordering constraints. Then I wanted to add constraints for all actions that have to come after the initial state and for all actions coming before the goal state. So this would be 4 new constraints. But in fact, I only have to add 1 because 3 of those were already implied by the causal links, and there's no need to represent the same constraint twice. Finally, you may notice that the values of these variables, the value of R1 and R2, must actually be the same value because this has to unify with robot and this has to unify with robot. So that means we're loading and moving the robot in parallel here, which will not work. And this can be resolved by adding yet another ordering constraint to this plan, namely doing the loading before we move the robot. And that's it. Adding ordering constraints was our final plan refinement operation.